following up from the last video I did, we're going to do some more waves. So here we have a displacement distance graph, okay? And it's a wave. And we need to find the unit that is represented on the horizontal and vertical axes. And as you can see here, it says cm on both, which means centimeters, so it has to be b. What is the wavelength? Now remember, from the last episode I showed you how to get the period from a graphed wave. That's using displacement time. In displacement distance, we can only find the wavelength, which is the same way as we found the period before. So what I'm going to do is, on this graph right here, I'm going to draw one hill, and then I'm going to draw another hill. And as you can see here, it's at 6. So we know it's at 6 centimeters. That is our wavelength. And we know, just to convert it into meters, because that's what the question asks, it must be B, because 0.06 m, and you can use your calculator for that, but we don't need to, because the only way it would work is if we had 6, because 3 centimeters would be 0.03 meters in this, and then 9 and 12 vice versa. So it has to be 0.06 meters. Question 13. Which equation allows us to find the frequency from wave speed and wavelength? So we need to figure out how to find frequency from wave speed and wavelength. What are our letters that we use to denote those things? Frequency is with F, as we know. Frequency is F. Wave speed is with V, and wavelength is with this lambda symbol. So let's look at our equations that we have here, A, B, C. Both C and B have T. T is for period. And we need to find frequency from wave speed and wavelength only, not with the period. So that means it must be A, which is true because it has the V, the F, and the lambda symbol. Now, question 14. Identify the amplitude and calculate the frequency of the wave. So as we look from here, the easiest way to calculate amplitude from this type of wave is to go from the middle of one of these hills and go straight up to the very top. As we can see here, it goes at 8. So it must be, so the amplitude, I'll just call it amp, will be 8 centimeters, because remember we're working with centimeters here. We're working with centimeters, so it has to be in centimeters. And so the frequency of the wave would be V equals F of the lambda symbol. The reason why it's V equals F of lambda is because we know that the speed is 18 ms to the power of -1, which is denoted for velocity, as we know. So it would be 18 ms to the power of -1 is equal to F multiplied by the wavelength, which is 0.06. So get F by itself, we divide each side of this equation by 0.06. So put that into our calculator right here. 18 divided by 0.06 would be 300 is equal to F. So F is equal to 300. And remember, we got to put a unit next to it. And for frequency, it's hertz. So Hz. And that is our frequency. And the amplitude is 8 centimeters. Nice.